An essential component in the scientific method is where we make our observations, collect our data, and then evaluate our hypotheses. In this segment, I'll be setting up a research scenario, explaining it, so we have a context in which to better understand hypothesis testing. Hypothesis testing is when we decide whether or not we can reject a null hypothesis and support our research hypothesis. For this illustration, our theory will be that vitamins affect mental functioning. We're going to have a two-tail hypothesis. That is, vitamins might improve mental functioning, or vitamins might harm mental functioning. That is, the results could go either way. If this had been a single-tail research hypothesis, then we might say that vitamins improve mental functioning. But for this scenario, to help make it easier to understand, we're going to stick with the two-tail hypothesis that vitamins simply affect mental functioning. To get started, we're going to need to operationally define our variables. We have the following variables: vitamins. We need to let the reader know, what do we mean by vitamins? What if someone wants to replicate our study? What type of vitamins do we give our participants? How much of the vitamins do we give our participants? We'll also need to talk about mental functioning. What do we mean by mental functioning? According to Gardner's theory of intelligence, there's lots of ways to evaluate mental intelligence. We need to be specific so that when someone later chooses to evaluate or replicate our study, they'll know exactly what we did. For this particular example, we'll simply define vitamins as someone who is receiving 24 ounces of vitamin water each day for 2 weeks. Everyone in our treatment group will receive those 24 ounces of vitamin water each day for 2 weeks. For mental functioning, we'll evaluate that with a standard IQ test. IQ tests will measure analytical mental abilities. Typically those mental abilities that are necessary and helpful in succeeding in school. For our research method, we're going to use a single sample and compare it to the general population. And this is possible because for the general population, we know that IQ is equal to 100. IQ tests are designed and standardized so that the average IQ is 100. So we know specifically what IQ should be in the population. Our treatment group will be selected from that general population. They'll be given 2 weeks of vitamin water, 24 ounces a day, after which we'll go ahead and compare their IQ to the general population. And we'll see if there's a difference. Our research hypothesis is that after the 2 weeks of treatment, that IQ will differ between the treatment group as well as the general population. That there will be a difference between these two groups. That they will not be equal. This could be because vitamin water improves your IQ, or it could be because vitamin water decreases your IQ. Our null hypothesis is that there will be no difference at the end of the 2 weeks. That both groups will be the exact same. If vitamin water was no different than just drinking plain water from the tap, then certainly we wouldn't expect people's IQ to be affected. Should we expect that vitamin water would improve people's IQ or decrease people's IQ? The null hypothesis says no, we shouldn't.